I want to first say thank you all for attending this Ingram Micro exclusive webinar for our partners. We wanted to give you, our partners, the opportunity to interact directly with some IBM experts around the Power 10 launch and get the exact enablement that you need as partners to help drive Power 10. My name is Mark Miller. For those that don't know me, I'm a field technical consultant on IBM systems for the East. Joined by my partner in crime, Cheryl Thompson, who's the senior technology consultant on the systems, excuse me, for the West. So you've probably interacted with us before. So we have Todd Boyd, who's on the product management team for Power 10, going to give us some great messaging around Power 10. And we have additional IBMers in the chat. So feel free to, if you have questions, drop them in the chat. Maybe we'll definitely leave some time for Q&A at the end, but we want to keep this session interactive and make sure that our partners get the information that they need. So Todd, I'll kick it off to you. Thank you.
Great. Thank you, Mark, and Cheryl for setting all this up, and thanks everybody for taking the time today. I will say this: if there's a question that's in the chat, because I'm sharing my screen, I won't be able to necessarily see the chat. So if there's something that comes up that I need to address on a slide, just somebody interrupt me and we'll address it right then. Much easier. It's much easier to do if we're all in the same room. I know it's very difficult now. I don't know how many of you have started traveling again, but I can tell you, I've started traveling the last 8 weeks, and everything they talk about on the news is true. The travel is horrendous. I've had flights canceled, changed, moved, and everything else. So anyway, but again, thank you very much. And I'm going to take you through a lot of stuff here. If you have questions, like I said, put them in the chat. We'll address them. If we can get back to you with them, we'll do that too. So, it's really very high level, what we're seeing around the world, what's going on, right? New delivery methods, what are clients after? Those operational efficiencies, how can they do things better, faster? More economically. And then, of course, pervasively across everything is just the cybersecurity risk. It's just phenomenal what these people are doing that are hacking into things, and we'll talk a little bit about our security. So I'm going to go through the upfront stuff rather quickly. I will hit a lot on the 1050 and the scale out, and a lot of the proof points and claims charts and things like that that we've been going over with clients and partners that are really resonating. So last September, we did introduce Power 10. We've had great momentum with that Power 10. The sales have been phenomenal. Fourth quarter last year, first quarter this year. Second quarter numbers are coming in and looking really great too. So it's been really good. And when we did it, right, we introduced a system that basically doubled the performance of what other people had out there. We did that in two ways. We increased our number of cores, and we have our 16 socket system available in the 1080. Last month, or last week actually, just over a week ago. I hope you guys all participated and saw what we announced. I want to take you through a lot more of that in some detail here. With that, we did do improved security. A couple things that we did is the transparent memory encryption. No cost overhead. There's no overhead from a software standpoint or performance standpoint. Better isolation and better trusted boot for all those cybersecurity threats. We've increased the memory bandwidth. We did things within the processor core around AI with our MMA and things like that. And then redundancy, reliability, the latest. In fact, just about an hour ago, I got the latest draft of the ITIC report. All the vendors get to review it before it goes out. It should be coming out in the next probably month or so, but I just got the draft to review that. So we'll talk a little bit about reliability too. As I said, back in 3Q, we introduced our high-end last week. we announced our scale out, our 2-socket and our mid-range systems. They will GA tomorrow. So they will officially start shipping tomorrow, although we have shipped quite a few through an early availability program. I don't know if anybody on the call actually participated in that or not, but if not, I hope you did. We actually have shipped hundreds of systems to clients across the world already with early access to systems, under NDA and everything. One delta that I will talk about is you'll notice that we do have a 4Q update. Just around memory is the main thing here. In our 2-socket space, our 1024 2-socket 4U box, today that will be limited to 2 terabytes of memory. And then in the fourth quarter, that will be increased to 8 terabytes of memory. No change to the system, just utilizing the larger DIMMs. And then in the mid-range today, well, tomorrow, once we start shipping, it will be limited to 8 terabytes of memory, and then that will increase to 16 terabytes in the fourth quarter of this year. And it's really just around the availability of those larger DIMMs. Everybody's hitting the supply chain issues, and we're no exception. Okay, so why do people want Power 10? Serve around 5 things here, right? The hybrid cloud, we've simplified things even more. A lot of things around utilizing Ansible to automate scenarios of bringing things up, starting partitions and all that kind of stuff. Resiliency, I mentioned reliability before. We have 25% less downtime than comparable high-end servers. Very similar in the mid-range and the low-end. Our scale-out boxes. One of the things, and I just talked to a client about this just yesterday, one of the things we do in our 2-socket servers that nobody else does is we have hot plug PCI. You can actually go up and pull out a PCI card and put a new one in. Nobody else can do that. Just another thing that we do. We've actually had that for the last couple of generations. We just don't tout it. And we need to do a better job as partners and ourselves as IBM to tout that. Security, I mentioned already, the transparent encryption. That encrypts that data all the way right out to memory. It's all done in the chip, so there's no overhead, like I said. And again, the AI from the MMA, and then sustainability, right? We can do the same work with a third less energy than the previous generation. It's over 50% less energy than a Power 8 generation. So we have great capabilities there. Just a reminder, this is what the chip looks like. With the 1080, we utilized a single Power 10 chip, what we refer to as a single chip module. We have up to 15 cores. In the 1080, we had 10, 12, and 15 cores. You will see 16 cores on this chip. It was done not as a hot spare. It was put in there. We developed it this way for yields, and we're getting great yields. There was actually an article talking about low yields. That is not true. Our yields have been great. In fact, we're downbinning some of our chips just so we can meet the demand of our lower core count offerings. But in the mid-range and the 2-socket space, we actually take 2 of these chips, put them into the same module, what we refer to as a dual chip module, dual chip socket. Put those 2 chips into the module, they're interconnected, and then we can get up to, we actually activate 12 cores on each chip. We have a 24-core module or 24-core socket offering, both in the mid-range and in the scale-out. A couple interesting things, and I've been talking about this with clients because I heard somebody refer to it this way. These chips actually have 18 billion transistors on them, which is incredible. It's up there in the second bullet. Little more interesting thing is, right, we do all the compute, and all those transistors are either on or off, and they can flip every cycle. And those transistors flip 4 billion times a second. So when somebody said it that way, it made me really take pause and think about it, right? There's 18 billion transistors. They all don't flip every cycle, obviously, but they can either be on or off each cycle to get the right answer, and it happens 4 billion times a second, which just sort of blew my mind. So that's the chip. And then the Power 10 memory technology, we've introduced our open memory interface. It is open, so other people could utilize it. And at the end of those, we utilize what we refer to as differential DIM or DDIMs. This enables us to put buffers on the chips and have better reliability, or buffers on the DIMMs and have better reliability. That's how we get 2x more memory RAS than industry standard DIMM with these 4U DDIMMs. And then it also enables us to get the better memory bandwidth. We've actually improved it to over 400 gigabytes per second. So we've improved versus our scale-out box by over 2x, and in the mid-range, it's about 1.7x. And we provide, over 2.4 times more bandwidth than x86 systems. As I mentioned before, the transparent memory encryption, we have chip kill technology to help reliability. And then the one thing we've added into our scale out or our 2-socket boxes is our active memory mirroring. This is a feature that we've had in the high end and mid range. We brought it down now into our 2-socket offerings, where we actually mirror the hypervisor. So it will alleviate any failures there, and you can keep running if something happens to the memory where the hypervisor is stored. Security, what's important here, right? Obviously, right? We want to be secure, and we have one of the most secure systems in the industry. And the way I always portray this is how does this happen? Well, we build the chips, we design the chips, we build the chips. Yeah, Samsung fabs them for us. We then develop and design and manufacture the systems. Oops, sorry, I don't know why it jumped ahead. Manufacture the systems. We develop the firmware that runs those systems. We own the hypervisor because every one of these systems comes with Power VM included as the hypervisor. And then on top of that, we have AIX, IBMI, and now with Red Hat being part of IBM also, we have the OSs on top of it too. So we can, I don't know why it keeps jumping ahead, I apologize. We actually can, control that entire stack. You compare that to what the competition does, where Intel builds the chip or designs the chip, they fab the chip, a couple others fab some of them for them too. They sell them to HP, Dell, Lenovo, whoever. They build the system, they build the firmware on top of it, and then you put a hypervisor, whether it's VMware or KVM on top of that, and then you go license the operating system, whether it's Red Hat, SUSE, whoever, on top of that. So there's no one person that can control that entire stack and ensure that it is optimized around security. We have many less vulnerabilities. You can go out onto the CV website and search for those and find all of that.
Hey, Todd, we have a question in the chat.
Sure.
Keeps asking in reference to, and Jim just responded in chat as well, but in reference to hypervisor mirroring, how much memory does this consume? And if you can get specific, that would be great, because it depends is a tough sell.
I do not know the answer to that question, and I'm not going to lie. So I'll take a note, or Glenn, you can take a note, and we can go find that. I don't know how you answered it, Glenn.
And the answer is it does depend, but it's predictable. So it depends how many LPARs you're defining, how much memory min max desired you're setting, so it keeps the translation tables in memory. And system planning tool will tell you for planning purposes, or HMC scanner will tell you how much beehive memory is actually in use, and then double it for active memory protection. So it depends is true, and you can know exactly both before doing it or on a running system.
So I like the way you said it at the beginning. It depends, but it's predictable and known. So if you know your configuration, we can tell you. Is that a fair assessment?
Yep, exactly right.
Perfect. Okay. Hopefully that helps answer that. I'm not going to talk anymore about security. Let's go talk a little bit about reliability. We've always had the most reliable, what's referred to as, I don't know why this thing keeps jumping, the most reliable mainstream servers. The most reliable are Z series. There's a reason you pay that much for them. But in the mainstream Unix and I'll say Unix and Windows spaces, Linux spaces, we are the most reliable. We have been for 11 straight years, 12 straight years, and it's soon to be 13 straight years. A little preview there for you. We have redundant cooling. We do all the bulk power redundancy, first failure detection and correction, all that kind of stuff that people know and love, and that's what you get out of our power systems. Last couple of events I've done, I've actually asked the clients, how many people have Power 9 systems? How many people have Power 8? Tuesday I was in Atlanta, and a couple guys had Power 7s, and somebody always has Power 7s. One guy still had a Power 6 box. And my comment is, how stupid are we? If we didn't build reliable systems, we could sell more, or sell them, replace them more often. But we take pride in our reliability and availability, and it is. There are lots of other reasons to bring systems forward and replace them with the latest and greatest technologies, such as the security and that kind of stuff, and some of the performance and the savings that you can encounter there, which we'll get into. One of the big things we've been really touting is how you migrate to a new paradigm around cloud native applications. And because of our versatility, right, we can continue to run those mission critical applications, whether it's DB2 or Oracle or SAP or any of those, on the latest and greatest technology with Power 10. They'll run better. We'll get into some of that. I'll show you some of the results that we have. You get all those reliability, availability, security, efficiencies that exist. But at the same time, we do a great job running cloud native applications. And in fact, I'll show you some results that we did on our scale out with some containerized workloads. And the savings that you can see there are just incredible. And one of the clients I was just with, that they were very interested in moving to a 1050 to run some of their applications, their AIX applications, to modernize them, utilizing some of the new NVMe capabilities that we have. And then at the same time, they're talking about containerizing some things with new workloads. And we talked about what they could see on that. And they were very excited to be able to put those into a separate partition right on the same box. And this is what we're really talking about when we talk about modernizing your environments. It's really across the board, from your traditional applications to your new and emerging applications. You can also do this both on premise and in Power Virtual Server, as you see across the bottom here, right? It's the same environment running whether you run on-prem in like a Power Private Cloud, or you run it on Power VS, our own IBM Power Cloud. You get all of the same performance capabilities, the same attributes, and the same security and reliability from that type of system. Okay, now the fun stuff. Let's get into what we really introduced last week and where those results are. So I know a lot of you have seen a lot of this, so I'll go really quick at the beginning and slow down when we get to some of the more interesting results. Our 4-socket mid-range, 3 processor offerings, 12, 18, and 24 cores, up to 16 terabytes, only 8 terabytes at GA tomorrow. The 16 terabytes will come out in the 4th quarter. We had a target of 30% price performance improvement. What we're anticipating is our 12 and 18 cores will really play in the AIX space. There is no IBM I on this system, so it's really just AIX and Linux, along with Red Hat OpenShift, obviously. But we would really drive clients to the 12 and 18 core for AIX, and that's really because around core performance and single thread performance capabilities. SAP HANA will be predominantly on like the 18 core, where we're anticipating up to like about a 12 terabyte HANA config, and then a 16 terabyte with the 24 core, 96 core option for 4 sockets. We are working with SAP for that HANA certification. It's not available yet, but it will be coming soon. We also anticipate using the 24 core in our healthcare solution edition. Again, something else that we're working on. But we went after that 30% better price performance versus the previous generation, and we were able to attain that. So the results are really great. The other thing we did is we're introducing, basic 3-year warranty. You can utilize Power Expert Care to upgrade that to 24/7. I think I hit everything on this chart. I guess I should mention we have 11 PCIe slots, and the one big thing, and this is what the one client I just referred to a while ago, all of our systems now are NVMe. So we are not doing internal SAS drives. They are all internal NVMe drives. So the performance capabilities that those bring with them are just incredible in number of IOPS and capabilities, response times, that latencies that you can get with that. This is a side-by-side of our 950. You see all the green that we've introduced from the 18 and 24 core, going up to 96 cores. So we basically doubled the number of cores in these systems. And we did not do it at the expense of core performance. We still get core performance improvements for these systems. In fact, on some of these, we're getting up to 39% more performance per core. And why is that important? That's important on those DB2s, Oracle's the predominant database in the world, and it's licensed by the core. So we have always driven to have better per core performance with each generation, and this is no exception, even though we actually doubled the number of cores in the system. I mentioned the OMI interface. We improved the processor interconnect, the memory bandwidth. Memory capacity stays the same, but we do move to DDIMM, so you get that improved reliability and bandwidth. Better PCI. We're now enabled for PCI Gen 5. We have 64 lanes of Gen 5. And all of the internal storage that I mentioned. Also, the memory power supplies, we're moving to titanium class especially for EU, but it's across the board. So for those of you that are familiar with our performance metric, what we publish every time we come out with new systems is what's referred to as the Power Performance Report, and our RPerf benchmark. Basically stands for relative performance. This table shows all of the 2, 3, and 4 socket across our 12 core, 18 core, and 24 core options for the 1050. If you look at moving from previous generations, so the left-hand side of this chart is Power 8 to Power 10, and the right-hand side is Power 9 to Power 10. So the top table is at a system level, either a system or a socket. So 4-socket E850 with 12 cores in the socket, or 48 cores total. If you were to move that to a 24-core system, 24-core based system with 4 sockets or 96 total cores, you could actually put 3 of those systems into one 1050 with 96 cores. That's the way you read the tables. You can see the gains are just quite dramatic. You can reduce the cooling, the footprints and the cooling costs by 2/3. You can put multiple of these systems onto a single 1050 as you move forward. Same thing even with Power 9, right? We're over 2x across the board. Now the bottom tables on the left and right hand side are the core performance gains. That's what I referred to before. You can see that from a Power 8 to a Power 10 processor core at the core level, we're anywhere from, I'll call it 50 to 100% better per core. So you could actually reduce the number of cores by a half. Even versus the previous generation with Power 9, right? You can go all the way up to 39% that I mentioned before, right? If you go from a 12 core to a 12 core. Even the 11 core, which is a little more popular, I know we didn't do as many 12 cores as the 11 cores. You're still at 37% core improvement, moving to a 12 core 1050. So they're just huge gains you can make. If you look at it overall, what we did here is we plotted the R-perf for each processor offering for Power 8 on the left, Power 9 in the middle, and Power 10 on the right. And we did both the 2, 3, and 4 socket numbers. Our 2-socket 24-core system, so 48 Power 10 cores, can actually contain better performance than any Power 8 or Power 9 system out there. It's actually a very incredible story. So you can, consolidate multiple of these systems, multiple Power 850s onto a single 1050. Okay. From a benchmark standpoint, what did we publish? We came out with a spec int number. We actually published 5-row records, spec int peak and base. Our 4-socket actually blows away the best x86 number out there. We published 1580. The best 4-socket, which is in the pink here on the left, is 846. In fact, we almost matched their 8-socket number. And I poked our performance team over and over, trying to get them to get that 1620, so we could say we had twice the performance with half the sockets, but we couldn't quite get there. But we do it in 96 cores versus their 224 cores. So this is where we're getting over 2 times more performance per core, 2.2x. And by the way, this is our slowest core in the 1050 because this is our 24 core based offering. Our 18 core is a little bit faster, and our 12 core is a little bit faster yet from a frequency standpoint. The reason being, right, you have less cores, you can put more power to each core, you can drive the frequency a little bit higher. So with our 12 and 18 core, you actually see per core numbers that are more on the order of like 2.6, 2.7 times. So it's just an incredible story of what we were able to do from both a core and a scaling standpoint. Very similar, we did the same thing with spec JBB. So, if you're running Java-based workloads, we actually set a world record for both max JOPS and critical JOPS. Again, blowing away the types of numbers that x86 is able to produce today. And then to me, the most interesting is actually our ERP workload. This was an SAP SD benchmark, so 2-tier. A little more realistic, right? Spec CPU, spec Java, those are really just compute based. They really don't stress the rest of the system. This puts a little more stress on the system than those compute centric type benchmarks. And you can see what happens here. Our 4-socket 96 core blows the 4-socket away and actually beats the 8-socket here. So where you're actually, stressing more of the system, you see where we shine even more so. Versus the 8-socket, we're over 2.6x better than what Intel can do. Even versus the 4-socket, we're 2.3x better. And again, This is the slowest processor we have in the 1050, the slowest core. The 18 and 12 core are going to show numbers that are, over 3x versus the 8-socket Intel. So it's really a great story, and the teams did a great job designing it, developing it, and producing these types of results. So what does this mean from an overall standpoint for a client? I talked about some of the per core numbers. This chart actually utilizes QPI, which is a performance metric from IDC. So it's a third-party performance metric. What we did here if you look at the table on the left-hand side, we took an 8-socket Superdome Flex 280 based on that QPI number of 187,000 that you see in green. We applied what we hear from clients is typical utilizations. In fact, I think we are on the high side here. For x86, we used 40% here. So you get 40% of the performance effectively. And then with subcapacity licensing that we do on our systems, on all of our systems, not just our 1050, we only have to license 22 of our 48 cores in a 4-socket E1050 with 12 core processors per socket. So there's 48 cores out there. We license 22, we activate 22, we license 22 for Oracle, and you match the performance. And what's this do overall? It actually takes the total solution cost, hardware and software, from nearly $3 million down to less than $1.4 million over a 3-year period. That's if you're buying new Oracle licenses, assuming a discount of about 60% for the Oracle Enterprise Edition license. Not atypical, that's sort of standard. If the client already has Oracle licenses and are only paying the maintenance today, they can still reduce it. It's not quite as dramatic. It goes from about 1.4 million down to about $750,000. Still, you're saving $700,000 over 3 years. You can take those extra licenses, you can repurpose them. You have room for growth. You can repurpose them to new workloads, new environments, whatever you need to do. Or in the end, you could also give them up, just stop paying maintenance on them to Oracle, and maybe you keep some to repurpose, maybe you give some back and just stop paying for them for the perpetual licenses. So I was on the Flex 280. I know we're running a little longer. We did the same thing versus a 4-socket, a couple of different examples that I've included here for everybody. And we can get you guys these charts too. So I want to jump to the scale out systems and get through some of that and leave a little bit of time for Q&A if there are any. So on the scale out side, we actually introduced a total of 6 new systems. Now, if you look at the right-hand side, which is our enhanced performance and scale systems, that's our S1022, L1022, S1024, and L1024. The S's and L's are basically identical from a performance and a feature set standpoint. The key difference is that on both of those, the L1022 and L1024, only 25% of the cores can run other OSs other than Linux. So if you want to run AIX or IBM I, you are limited to 25% of those cores. List prices are the same, performance is the same. Overall net price will be lower on the L boxes than on the S boxes. I'll start on the right-hand side, and then I'll work our way back to our entry systems. For the S1022, you can see we go up to 2 sockets and 40 cores. So 20 cores, we have a 12, 16, and 20 core option, and 4 terabytes of memory. This one will be limited to 2 terabytes starting tomorrow. On the S1024 and L1024, so higher performance 2-socket systems, we go all the way up to 48 cores. Again, we doubled the number of cores versus the Power 9 system. Our 924 only went up to 24 core total. This goes to 48. We are increasing the memory. It will go up to 8 terabytes on these systems versus the 950. I'm sorry, 924. So a huge improvement there. Again, all of these systems are NVMe based, U.2 bays on each one of the systems as the base for boot and everything else in the internal storage. Jump back over to the very left-hand side. These are what we refer to as our entry systems. Now, our entry systems compared to the enhanced systems, much like the 1050, we utilize that DCM or dual chip module, where we put 2 processor chips into a module and put that into the socket. On the S1014 and the S1022S, we're actually utilizing what's referred to as a dual chip module, but one of the chips is not a processor chip. It actually acts as a switch chip to get you to the I/O and memory. So it is a single processor chip within the, or single compute chip within the module. The 1014 is limited to 1 socket, so we are only limited it to 4 and 8 cores per socket. And then the 1022S, we utilize the same module, so we can go all the way up to 16 cores in the system. Clients that are running Oracle Standard Edition, the 1022S is where we would direct those clients. And again, right, we had targets across the board of 30% better price performance. We actually got 32% on the entry systems. Some of the 1014 systems where we're running more IBMI type workloads, it's even better than that because the performance is quite dramatic with IBMI. And I'll show you some of those ratios too. I've got side-by-sides here of each one, 924 versus the 1024. You'll notice the name change, right? We used to have the S924 and H924, H for HANA. Now it's the S and the L. We didn't want people to have the thought that it was only a HANA box. It's more of a Linux-based box for the L1024. And that's why we're limiting the number of cores that can run AIX and IBMI. Again, you see all the differences, very similar. Total memory bandwidth, right? We're over 800 gigabytes per second. Here's where we've increased our memory bandwidth by over 2x versus the previous generation. Very similar for the 2-socket 2U. This one, we do only go up to 20 cores. It's 12, 16, and 20 as opposed to 12, 16, and 24 on the 1022. That's really just due to cooling that we could cool and the trade-off of performance versus the cooling capabilities that we had. Oh, and in the middle, you see the 1022S with the 4 and 8 core systems. Okay, again, our perf, we've got all the systems here. We do not offer 1-socket systems on the 1022 and the 1024s in the 16 and 20 core version on the 1022 or the 16 and 24 core version on the 1024. So if you want a single socket system, you would have to go down to the 12 core. And part of the reason for that is we have introduced capacity upgrade on demand on these S1022 and S1024. So you can buy a 2-socket 32-core system on a 1022 or 1024 and only activate the number of cores that you need to activate. That will help reduce the total cost of acquisition at purchase time. On the bottom are the 1022 and 1014 RPerf numbers. You'll notice we do not offer a 2-socket 4-core on the 1022S. So you can get a 4-core a 1-socket 8-core, 2-socket 16-core. Very similar performance ratios. This is all based on our perf for 1022. These are all the migration scenarios. You can see again, we're over 3x versus a lot of the 822 offerings. And again, huge core performance gains, anywhere from 40 to, I'll call it 80%, 78%. And versus Power 9, we're all the way up to 40% per core numbers here. 1024, again, very, very similar. Almost the same results per core as on the 1050, because we're at the 24 core option, or 24 core option here. Side by side on the 1-socket 4U, very similar types of deltas. I want to get to some of the performance numbers. These are the CPW numbers I want everybody to have. I mentioned some of the how good the IBM-I gains were. You can see that here. If you remember, the percentages on the other pages were, peaked out at about 80%. You can see some of the per core numbers here were over 160%, even up to 180% versus the 4-core option. So, some really great ratios for those clients running IBM-I type workloads and utilizing the CPW benchmark in that space. Okay, these are the ones I want to finish up with. These are workloads, or I call them workloads. They're not benchmarks. I cannot call them benchmarks. These are workloads that we've run on our scale-out systems, generally using our 1022. And this really touts as we move to more and more realistic customer workloads, right? From those benchmarks to QPI to now even more realistic, where you're stressing more and more of the entire system. You see some of the per core numbers here. This was actually running an OpenShift container platform on both a 1022 and on an Intel-based 8380. So we ran on a 40-core, 2-socket, 20-core per socket, 1022 versus an 80-core 8380 system. So it's the Intel's latest and greatest 40 cores per socket. Our 40-core actually outperformed their 80-core almost 2x, right? We hit nearly 77,000. They were at 43,000. Per core, we're over 3.6 times per core. Just an incredible number to reduce that core licensing count, our core licensing cost. And guess how OpenShift is licensed? It's licensed per core pair, actually. This one actually utilized WebSphere and also OpenShift. So you can see what we're able to do. Even though the server price is more, it's about $70,000 more for the server. Over 3 years, you're going to save over $1.4 million. So, just huge savings potential for clients as they're utilizing these 1022 systems. Another similar one, this is actually running MongoDB, a containerized geospatial workload with MongoDB, so an open source database on top of OpenShift. Again, very similar. We're getting over 4 times more containers per core. You're getting about the same solution cost and getting over 2x more containers at a similar TCO compared to the Intel-based system. This one, the reason that you don't get that huge price or huge cost savings is because this is not licensed per core. It's actually licensed by the memory. So, the software cost is about the same, but we're able to do more containers in the same footprint and the same space. And that's what's key that we're able to do. Very similar is Postgres, EDB Postgres. We're over 20% more at the system level performance-wise, over 4x per core. Those of you that are not familiar with EDB and Postgres, it's a great replacement for Oracle. It utilizes the same schemas as Oracle database. So, instead of that list price of an Oracle license of $47,500, these are licensed at around $2,000 per core. So you get very similar performance, huge software savings, and running it on the power system. What we did here is we actually ran on 16 cores and outperformed the Intel 56 core by over 20%. So just huge savings. And think about what you can do here, right? You can buy a 32 core 1022 system, activate 16 cores, license 16 cores. If you want to put more workload on it later, you just activate more cores and turn them on, and you can grow workload or put a different workload, put an additional workload on top of it. If you already have a system that you're running, if you buy a Power 10 system and are running your traditional workloads like we talked about before, you can then turn on cores and just utilize them to run this new EDB type workload. You can do the same thing for the Mongo on the previous page or whatever. So all those things are very similar. One of the last things I'll talk about is something we did with our MMA engines. We work closely with DB2, and DB2 utilizes the matrix multiplication that we built into each processor core. So they are able to do fraud analytics much faster, much better, and much more efficiently with Power 10 than they are able to do it on x86. So if you're running DB2, it's actually DB2 Advanced Edition. You get about the same performance. They're slightly ahead of us in performance, total throughput, but we're doing it at about $1.7 million versus $4 million for doing it with an x86 system. And again, it's a 16 core. You have 16 more cores sitting there you can utilize for your traditional workloaded environments. There are a lot of other things we've got. We've got multiple versions of this stuff. It's all available out in the claims deck. I know all partners have access to that. It's all out on Seismic. So you can go pull those down and utilize those with clients as you move forward. The other thing I'll point out is from a TCO perspective, I believe Ingram has a deal. I'm not positive, but Cheryl or somebody can verify this. But you can utilize Precision IT. They will do TCO studies for clients.
Yes, we have a working relationship with Hayden and team.
Excellent. In fact, I was just texting with Hayden this morning, Cheryl. I'm so glad to hear you say that. I meant to ask you that ahead of time. So yeah, Hayden's a great guy with Precision IT. So team, if you need TCO studies, they're great to work with. They can onboard you. You can do them yourselves. They will do them for you, and they're fabulous to work with. So last chart I have is just OS support matrix. You can see here what's running in P10 mode, what we're going to do AIX 7.3 across the board. You can run AIX 7.2, but it will be in P9 mode. And then AIX 7.1, you have to have TL5 on the system or TL5 with version of AIX in order to run it on Power 10. IBMI, very similar. You see the TR levels, the refresh levels that are required, and then the same thing for RHEL here too. I just want everybody to have all that. And with that, that is my last chart. And we have 9 minutes left. So Cheryl or whoever, we can open it up to questions, whatever you want to do. I feel that.
Absolutely. Want to open it up for questions. I attended the Dallas session and the Q&A piece of it was invaluable. So to our business partners, please unmute your mics and ask the questions. We have Glenn Cornu, who's here from, well, lives in Austin, but he's also a technical specialist on the power system, and also Jim Smith, who is our technical advocate for Ingram Micro, and of course, Todd. So if you have questions, please unmute your mic or put it in the chat box.
Yeah, questions, concerns, anything, feedback that you want to share. Feel free to unmute
There was
yourself.
a question on the new power supplies on the mid-range, whether they're just unplug the 950, plug in a 1050. We need to do a little bit of research there. Reach out. Energy Estimator is the tool we'll use for that. And if you look at Energy Estimator today, you'll see that it's 1080 only, but at GA tomorrow, Energy Estimator will have all of Power 10. So
Right.
tomorrow we can take a look and answer some of those questions.
And to all our partners on the call, we do have a session with the Power 10 technical deep dive, and Jim Smith will be our presenter then. So if you could, click on the button there in the chat and register for that session on August 2nd.
And I'll probably have a couple of compatriots with me as well.
That's great, Jim.
And we will also be featuring expert care. As you know, these units are also now in eConfig from a system maintenance perspective, expert care. So we will have someone from TSS speaking on that.
And just as a reminder, the session was recorded, and once I get this uploaded, I'll share it to the entire registration list. So if anybody in your organization couldn't make it or had to drop early, wanted this information, you'll have the recording as soon as I can get it.
And I just want to make a plug. If you had questions around NVMe, hopefully folks got a chance to listen to the NVMe deep dive session that Douglas Gibbs just did a few hours ago. But if not, that was also recorded, and playback of materials for that should be available in a couple days.
And especially from an IBMI perspective, Doug had some awesome tidbits of information there.
Keith just asked in the chat if the 8.2 deep dive technical will be recorded, and yes, it will. And we'll be sure to get that out as well. Okay, we'll go ahead and wrap it up. And thank you so much for attending, and looking forward to all your Power 10 business. Thanks a lot.